Okay, here we go. First lesson. You may be wondering why I'm starting at chapter one, section two, rather than 1.1. And I've found over the years that starting from 1.2 is the best way to start geometry. So here is your homework. And reminder, this is a video, so if I flip the slide very quickly, you can always pause and rewind, or rewind and then pause. As always, if you've had me before, remember, make sure you put a title on your homework. I'll see you the day after you do this assignment. Make sure your name's on it, my name, the date, the section that this represents. So, in other words, the first one's 1.2 in geometry, and then do the problem and circle your answers. Occasionally, tonight's a good example where there really are, or many of the questions don't involve work. So your homework might look like this for tonight, but most of the time there's work involved. So typically, which is why this says work must be shown, the homework will not look like this. So make sure if there's work involved, you show me the work. If I've never taught you before, there are squares in the upper right-hand corner of some of the slides. A red square means that you're going to be taking down some notes. A blue one means that I want you to do the work with me. I'll walk you through a problem. And then lastly, if it's green, that means that I want you to do some all by yourself. All right, so here's how geometry starts. The section is called points, lines, and planes. And as you can imagine, it's going to be about points, lines, and planes. There's three objectives. After we finish each one, I'll read the objective to you. All right, some of this is going to come very fast. Luckily, you're on a video, so you can hit the pause and rewind and write down the notes. All right. I will also refer to where your notes go as the book of truth. All tests are open notes. You can use a calculator on every single test. Well, I guess the first question is, so what is a truth? And I'm going to say a truth is something that isn't a lie. That begs the question, right? What is a truth or what is a lie? And I'm going to rely on the common sense definition of truths and lies. Some truths, however, are accepted without proof. You don't need proof that your mom's going to be upset with you if you have a messy room. You don't need proof of that. You've learned from experience. Other times you need proof. Your mom picks you up and she goes, "I baked you a cake tonight." And well, I mean, you trust your mom, and she probably did, but you're probably, wait, is it really a cake for me? Sometimes you need some proof of that. There's no difference in geometry, the same thing in our book of truth. We only write things that are true. Some things we will prove. I will teach you how to prove things in chapter two and three. And then some you will accept without proof. And so, what are those things? For example, a definition is something we accept without proof. Anybody can make a definition as long as we all accept it. For instance, this is called a triangle. You are familiar with that. That's a definition. That's a polygon with three sides. Nobody proves this to you. Nobody counts the three sides. That shape is familiar to you because you've been told that is a triangle. Now, we're pretty far away from getting to triangles. I've just used that as an example. All of geometry starts with one basic idea. Everything from geometry stems from this one basic idea, and that is the first vocabulary word we're going to put in our book of truth, and that is this thing right here. Yes, it sure looks like a circle, but no, this isn't about a circle. This is about a point. And the actual definition or the geometric definition of a point is simply it's a location. Notice it's not a shape, it's just a location. This one's bottom left. Um, Accompanied to that is the second sentence there that says the points have no size. So it's not big, it's not small, it's not fat, it's not thin, it's just a location in space. We'll always talk in geometry about how do you name things. So how do you name points? Points are historic and traditionally named with capital letters. So we've got point, a location, doesn't have any size. You can use any shape to represent a point. Generally speaking, people use dots or circles, but I've seen triangles represent points or squares, rectangles. And then lastly, how do you name it? Capital letters. The capital letter can go on the top, it can go on the bottom, it can go on the left and the right of the point. You can even have it a bit of a distance away from it as long as there's an arrow pointing to it. Capital letters or points get capital letters. All right. When we write it in a sentence, occasionally in geometry, we'll be writing sentences. You simply write point A. All right. Imagine this. If I ask you to think of every single possible point, not just 1 point or two or three or four, but every single possible point. Well, together they would not make a rectangle or a square. They would make everything, right? It wouldn't be restricted to just this size. It would be everything, all possible points. If we imagine this in 3 dimensions, that would be everything. What is everything? Some people would say the universe. In geometry, we would say space. So space is simply the collection of all points. Collection in math is called a set. So we say the set of all points. We have no designation for space. Sometimes we use a U universal set, but in geometry, we don't have a specific designation for space. All right, everybody good? Moving on. Now we'll get to some recognizable shapes. The first shape that we actually start with, these are all built from points, is when we start with 1 point and we place another point somewhere on the page, and you guessed it, we're going to play connect the dots. Now remember, since A and B have no shape or size, then there is an infinite number of points between A and B. We simply choose the two endpoints for the shape. And hopefully you realize that this shape, you've seen it before, is called a segment. So a segment is not a line, it's part of a line, and it connects 2 points, and it must be the two endpoints. There's an infinite amount of points between A and B. They're not named here, but if they were named, we cannot name that shape right there by anything other than A and B. Okay, so that takes care of the shape. How do we name the segment? The segments are named, we can kind of figure this one out. If they're designated by size by their two endpoints, then we should probably name it by their two endpoints. Notice I not only wrote capital A, capital B, but I put a little symbol above A and B, and that symbol is, yep, it's a segment. Now, hopefully, immediately you saw this and realized, well, why did you start with A? Could you not have started with B? I could, as long as I use the two endpoints. So here are two different names for the same specific segment, either segment AB or BA. It's whichever one you want. And if you're writing it in words, notice there's the symbol for, sorry, there's the symbol. If you're writing this with words, segment AB. All right, there's a but here. What would happen if I put a point and named it in the middle? Remember, there's an infinite number of points. Well, I will not call this now segment ACB. And mathematicians are very efficient. All segments will be named with two letters, not three or four or five or six. We will only name it by endpoint. So if you do have a point or points between A and B, you just can ignore them for the sake of naming the segment AB. If that didn't make sense to you, rewind the video, play it for yourself again. However, right, there are multiple segments here. The longer segment is AB, but there are shorter segments here. And for instance, that segment that I'm indicating right there, that is segment AC or CA. Does that make sense? Okay. Now I want you to take a look at this segment. I want you to take a moment. You can pause after I ask the question. How many segments are there? So how many segments there are, ask the question, how many unique or different, not different names, right? I'll talk about the large segment there, XZ. XZ is the same as ZX, but how many different size segments do you have? In geometry, we say by inspection or by observation. It looks to me like there are three different size segments. You got a small one, XY or YX, those are the same segment. You got a medium one, YZ or ZY, and lastly, you have the large one, which is XZ or ZX. Did that make sense? Remember, each one of those segments, right, has the segment symbol over the top of the two capital letters. Okay. Sometimes in geometry we have rules, and many people would say that's a dumb rule. The rules are simply the rules. I will point this one out to you. You can decide whether this is dumb or not. There's a green segment right there. I just told you we named segments by their endpoints. So clearly that is segment AB or segment BA. That's the name of it. If I actually measure that segment with a ruler, let's say, for instance, I find out that that's 2 feet long, then here's what geometry says to do. If you want to state that segment AB is 2 feet long, well, it's big but, this is what you do. So if we're talking about measurements of segments, this is the first confusing thing in geometry, we write it like this. And I want you to notice the difference. When we have names of segments, we have a segment over the top of the two letters. When we're talking about the size of the segment, we erase that segment symbol. And for many people, that's a little hard to accept at first. It's just the way we do things in geometry. Whenever you see no segment line over the top, they're not asking for the name or to find it, they're asking what is the distance. When they're asking what the name is, you must put that segment over the top. If you need to hear that a few times, rewind, play, rewind, play, rewind, play. Okay. And yes, it does seem silly at first. We have lots of silly rules in geometry, and I'll show you them when we get to them. All right, let's have another shape. So many of you wanted to do this one first. Now, I say this is the challenging one because of the consequence of the definition. I'll explain that here in just a second. All right, so think about this. Looks like I'm making a segment, not 1 point, but 2 points. And now I'm going to play connect the dots for sure, but I'm going to continue to go past A and past B. Those arrows indicate that we're going past A and B. Clearly, you probably already figured out that this is a line. So a line is an infinite series of points that extend in opposite directions. So we would go past point A and point B. Okay, so how do you name points? Well, just like you name segments with 2 points, we're going to name lines with 2 points. I'll explain that one here in just a second, why we name it with 2 points. But the question is which 2 points? Because lines go on forever. There are no endpoints. So here's the deal. Lines are named by any 2 points on the line. So for instance, this here is line AB. It's not a segment, so notice the symbol. The symbol is a line or line BA. Sometimes when we draw lines, we draw many lines, and it would get very messy if we had to name them by 2 points in every line. So what mathematicians is a secondary way of naming a line is they'll put a lowercase italicized or cursive letter somewhere directly above the line. Notice there's no circle there next to N. We're not saying there's a point N there. We're just saying that is line N. So this is line N, or in word form, line N, or line AB. Either one works. Now I'm going to stress one more time, lines can be named by any 2 points on the line, or by a lowercase italicized, excuse me, a lowercase or italicized letter. A lowercase, italicized, or cursive letter. All right. So if we look at this shape right here, clearly it's a line. So this is line GR. That's pretty simple, or RG. But what happens if I put a point in there? There's the but. So if I put a point there, well, then we have lots of options. Well, I already said it's called line GR or RG, but it's also line B. Wait, I put a segment there. I can't put a segment line there. I got to put a arrow segment to represent a line. So not that, but any 2 points to find a line. So yeah, that's line BR or RB or GB or BG. And notice all of these, since any line can be named with 2 points on the line, all of these are the same line. And there's no preferred way of doing it. Just pick 2 letters and away you go. Make sure you understand that. This is the first somewhat complicated concept in geometry. Lines can be named by any 2 points on the line. All right. Um, of all the vocabulary we've done so far, you've probably been familiar with them. So here's your first one you're not familiar. Imagine if we had a line with 3 points that were named. Remember, lines have an infinite series of points, but I've named 3 points. They're A, B, and C. Notice all the points A, B, and C are on the same line. There's not 2 lines there, there's only 1 line there. If you have points that are on the same line, the relationship between the points they are collinear. 2 L's, collinear. So collinear points are points that all lay on the same line. Points that are all on the same line. Okay. Well, it also begs a question, right? Well, what's the opposite of collinear points? Those would be points that are not on the same line. So, for instance, A and C are collinear, but A, B, and C are non-collinear. You cannot draw a line through A, B, and C without curving, right? You're not allowed to curve the line, and it's not a line by definition, doesn't go in opposite directions. So curves are, we have curves. We'll get to curves eventually in geometry. But if we're talking about collinear, all 3 points must line up in a line, pun intended. Right? So this would be an example of non-collinear points, points that don't all lay on the same line. By the way, if you have any 2 points, you can always draw a line between the 2 points. But if you have 3 points, sometimes you can draw a line, and in this case, you can't. I can draw a line between A and B, B and C, A and C, but I cannot draw a line between A, B, and C. It would have to curve or make an angle. All right, for homework, they're going to give you a shape and ask you to name everything that we just did. They're going to ask you to name all the points. They're going to ask you to name all the segments. They're going to ask you to name any line that you see. They're going to ask you to name collinear points, and they're going to ask you to name non-collinear points. So take a moment, pause, come up with the answers, and then play, and I'll give you the answers. Okay, so what are the points? Well, everywhere you see a circle there, A, B, C, and D are points. What are the segments? Well, AC is a segment, BC is a segment, BD is a segment, that's the longest one, and CD is a segment. Now notice I said BC, I could have said CB as well too. So I only gave you one way of naming each one of those unique segments. So there's 4 segments that you see there. Lines, there's only one line there. You have options here. You can name it by 2 letters. Any of the collinear points, you could name the line by that. So for instance, that could be line BC. You could also call it line CD or BD or CD. And lastly, you could name it line T. Any of those work. Collinear points doesn't specifically say to name 3. Usually it'll say name 3 collinear or 3 non-collinear. So I'm going to name 3. So B, C, and D are collinear points. They all make the same line. You could have said AC. Those are collinear points. Non-collinear points, you're going to pick 3 don't make the same line. You could pick 4 if you wanted to. So B, C, and A do not make a line, or B, D, and A, or C, D, and A. They don't make a line. They make an angle, but they don't make a line. You cannot curve, you cannot make an angle if you want to be collinear. They have to make the same line. Okay, I have more practice for this. Pause the video, then I'll give you the answer for each one. Oops, sorry, for each one of these again. The points are C, N, and V. The segments are NC and NV, or say that opposite, VN and CN for the segments. All right, one more time or the last time. The points are, pause if you want to get the answers. The points are W, T, K, and H. The segments are WT, WK, TK, and TH. The lines, I'm just going to pick 2 points on the line, WT or line N. There are more options there. And then lastly, the collinear points are WTK, and the non-collinear points, I'm just going to name one of them, WTH. How about that? Okay. This next one is, I can't tell you how big this is. It's super big, and if you get it the first time, you probably don't even need to write it down because it will be an obvious truth and it will sink in. So this is big. This is big, 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 which is why I'm making this flash. Okay, so the question states how many points define a line or a segment. What they're asking is, what's the fewest number of points you can have to actually draw a line or a segment, right? And here's the answer. If I draw 1 point, and we'll restrict ourselves to lines. It's the same thing for segments. How many lines go through point A there? Well, clearly one does, right? But there's another line that is nothing like this one right here, that goes through point A. So how many lines can you draw through point A? Well, it looks like I could do that process for a long time. In fact, there's an infinite number of lines that go through point A. But watch this magic. If I simply add one more point and I ask you how many lines can you draw through A and B, well, there's only one line. You could not draw a second line because it would have to curve. So when we say how many points define a line, we're not saying how many points are in a line or segment. That's infinite. We're saying what's the fewest number of points you can have and make a specific line, and that's 2. So 2 points define a line or segment. Play that again if you need to hear that. Well, that's our first objective. We defined and named points, segments, and lines. Moving on. Imagine this, and I usually tell kids in class, I say, put your hands on top of your desk and feel the surface of your desk. Now imagine that that goes on forever in all directions. So here's the top of your desk. And so it's going to go left and right and up and down or backwards and forward. What it won't do is up and down. In other words, it's not going to have any thickness, right? We have now defined what a plane is. A plane is just a surface, right? It has no thickness and extends in all directions. Well, how would you be able to draw that? Well, in geometry, we represent, notice I didn't say it is, we represent a plane by a parallelogram, that blue parallelogram you see on the screen right now. That's not the whole plane, because remember the whole plane goes in these directions, not up and down, because that would have thickness. So planes have no thickness, but they do go in all directions except up and down. Okay? To name a plane, we need 3 points now. So any 3 points on the plane can be used to name the plane. Could you name it with four? Sure. Those points would have to be on the plane. Well, how do you know if the points are on the plane if I'm only drawing part of it? It is customary that if the points are on the plane, they will be drawn inside the parallelogram. So all three of those dots, points, are inside the parallelogram or the plane, so therefore they are on the plane. So this is plane ABC or plane BAC or plane CAB, any of those combinations. You will also see this done with 4 points as well, too, either 3 or 4 points. And yes, typically, usually the points are on the, well, I don't want to say they're on the corners of the plane because planes have no corners. The plane goes on forever. But when we draw it with a parallelogram has corners. So typically we name planes by their corners. There are parent corners. Yeah, that's more accurate. Lastly, sometimes we don't want to, we'll have a very complicated diagram. We don't want to have points on the corners of our parallelogram. So there might be just a capital letter inside the plane or on the plane, and that we would say is plane B. You probably need to pause and rewind and play that again to make sure that sinks in. Okay. If you were in class right now, I would ask one kid to hold up a piece of paper. I would take a pencil and I would jam it through the paper, like literally through the paper. And I would ask you to look at this shape. Imagine that in your head. It's really easy to understand it in 3 dimensions in real life. But in 2 dimensions, how do we draw that? Well, there's plane M. There's point A on plane M. And here's a pencil, except it's a line J that goes through A that's on plane M. If you need to pause and rewind and play that again, do that. Notice if the line goes through the plane, we would see some of the line and some of the line would be covered up by the plane. That would be the dotted portion. So the plane starts above, or the line J starts above the plane on the left, goes through point A and goes underneath the plane. That's the dotted portion. Now, if it was up to me, the entire thing would stay dotted, but it is customary when it goes up. It's not going off the plane. It's just because we represent a plane by a parallelogram. That line portion there on the right, that's solid, even though that would be below the plane. Most likely, you might have to do this for yourself to get an idea of what I'm trying to show you here. Take a piece of paper, stick a pencil through it, and look at it. That's what we're showing right here. Okay. Where's line K? Well, line K is inside the parallelogram, so that means it's on the plane. So line K lies on plane M, right? I'm going to let you decide whether you need to put this in your notebook or not. You see point A? Point A is inside or on inside the parallelogram, so it is on plane M. So is B, and so is C. So just like we had collinear, we also have coplanar. And coplanar are two or more points that lie on the same plane. And we will represent that in 2 dimensions here by those points being drawn inside the plane. If there are any points not drawn inside the parallelogram, then that would be called, take a guess, that would be called non-coplanar. Point A and D are non-coplanar to plane M. They don't lie on the same plane. Okay, we're down to one last thing. All right, so the next idea, let's say I have a line, there's line M, and let's say I have another line L, and they both, because they go on forever, at some point they either are parallel or they intersect. And if two lines intersect because they're straight, they can only intersect in one spot. And so we call any two shapes that occupy the same space right, as an intersection. Got it? Okay. Intersections can happen with any shape, lines, segments, and planes. All of them could intersect. So let's intersect two planes and think about this. There's plane M, right? Point A is on plane M. If I draw a line through it, then that line J must intersect point or plane M. And since it's a line, it can only intersect in one spot. That's point A. That's what it's going to look like. However, planes can intersect other planes. I would demonstrate this physically in class, but here it is in two dimensions. There's plane M, and plane N intersects plane M. Now we're going to ask you, where do they intersect and what shape does it form? And so where do they intersect? I would argue this red line intersect or represents where the two planes would intersect. So for homework, when it says what is the shape that is formed between the intersection of two planes, well, it looks like a segment right there, but remember, planes go on forever. So it turns out that, where two planes intersect is not a segment, it's a line. Make sense? Because that's it for today, right? For homework, you're going to have shapes like this. I'll just point out when things are in color. For instance, this one in the geometry textbook, it means there's three dimensions involved. That's plane M, and we have line XY that goes through the plane at point O. And then we have, let's see, lines TW and RS that are on the plane. And then you can see some questions over there. Here's a box. It's in color, so therefore it is in three dimensions as well. All right. Well, that does it for this lesson right here. So you have 1 through 26 all for homework. Get your homework done, and when you're done with it, bring it to me. Let me look at it. I'll ask you some questions to make sure you know the material, and then you can go on for the next section. All right. See you later.